Hello and welcome. My name is Jeff Black. I'm the training team leader at Water OT Solutions based in Brisbane, Australia. In this series of demonstrations, what we'll be looking at is some of the new features that have been provided for us in SQL Server 2017. In particular, we'll be looking at adaptive query processing. There are many different things that adaptive query processing can do for us. And in fact, most of the situations where there is some estimates on row counts that may be a little slightly out, sometimes the execution plan that gets selected by the query optimizer may be less than optimal. So the adaptive query processing addresses these poor cardinality estimations by the use of batch mode adaptive joins, batch mode memory grant feedback, and interleaved execution. So this series of demonstrations will cover each of those three main factors and see how we can actually take advantage of those in our SQL 2017 databases. First, we'll look at batch mode adaptive joins. This is where the selection between different join types is made at execution time. There is a new join operator that will appear inside your execution plans when your queries are run against a SQL Server 2017 database where its compatibility level is set to 140. And this is in fact really just the easiest way to invoke the adaptive query processing. Of course, column store indexes do come into play here, and of course we also have a select statement to retrieve some rows. So what I'll do in this little demonstration here is to show you how this can actually work. So first of all, we're going to create a stored procedure to demonstrate the behavior of this new adaptive join operator that we'll see in the execution plan. First of all, the prerequisite, of course, is to set the database to the compatibility level 140. This makes it a SQL 2017 database. I have a data warehouse example database here that you can access by downloading from GitHub as well. And what we're going to do is use some new statements here to clear the procedure cache so we can have a fair test. What we're going to do is create a stored procedure, and our select statement is actually going to be wrapped up inside this stored procedure. And we're going to see the execution plan for that real soon. So let's just create the appropriate objects in the database, and we'll go and have a look at what the adaptive join operator actually looks like. Now this query that I've got here for a quantity for my orders out of the fact table here in this data warehouse, for all quantities above 360, this should be returning at least 200 odd rows or slightly more. So what I'll do is I will highlight this query, and I'll go to the query menu, and what I'm turning on here is the actual execution plan. So you can see the execution plan little button is sit there. Alright, so while we're here, we'll just go and execute this query, and this will give us our execution plan here. So the operator that we're interested in here is this adaptive join operator. Now if we zoom into this and have a look at some of the statistics around this, what we're looking for first of all is this number here, the adaptive threshold rows. Now, if the row count as the query is executing is more than that threshold value of 68, a hash match join algorithm will actually be used. Okay, as you can see here, this is the estimated one, and of course the actual join type, which is what we're more interested in here, okay, is the hash match. As you can see here, 206 rows are actually being returned. So 206 greater than 68, so we're above the threshold for the adaptive operator to choose the hash match algorithm. Now what we'll do with the database is actually go and change some of the data there. We're going to remove some of these rows here and of course clear the cache just to make it a fair test. And then we'll hit this here. Okay, and now this time the stored procedures should return less than 10 rows, which will be less than the threshold rows value, so hence a nested loop join semantic will actually be used. So let's execute this query and see what happens to our execution plan. If we zoom in now to our adaptive inner join, we'll see here that the actual join type used for this was nested loops, and we can see that the adaptive threshold rows is now dropped to 13, and the actual number of rows is 5. so are less than the adaptive threshold rows. So in this case, we'll use a much more efficient algorithm to do the join type here using nested loops. And hence we get a much more efficient query. So as you can see from this example, it is quite straightforward to actually use some of these new adaptive query processing features. Batch mode adaptive joins, of course, as we mentioned there, you've got to have your database compatibility level set to 140. It's a select statement, and you would also have noticed that the column store index was used. The column store indexes uses batch mode processing. If you want to know more about column store indexes, you can look at some of the other demonstrations that we've provided for you on the Warty IT site. So thank you for watching, and we'll have some more demos for you soon.